Morning, and welcome to the first of the 2026 Open Data and Open Knowledge sessions. My name is Leo Chilwane from South Africa, and I'm one of the co-chairs of the GEO In-situ data subgroup. I'll be your moderator for this session. So over the next 75 minutes, we're going to spend our time with what is arguably an indispensable layer of Earth observation, and that's in-situ data. The measurements taken on the planet rather than off the planet from orbit. So think about it for a second. Most Earth observation products you've ever trusted, every map of sea surface temperature, every land cover classification, every air quality alert has been or were calibrated and validated against measurements taken by a person, an instrument, or a community somewhere on the ground. So without that in situ backbone, the view of Earth observation is incomplete. And yet, as those of us working with in situ know, and as acknowledged by the GEO community in general, the sharing of in situ data remains limited, fragmented, and full of gaps. So that's the problem we're trying to tackle in this session from 5 complementary angles. So I'll just give you an overview of what you're going to hear today. So we've got 5 speakers, the first being Alessandro Turco from EPOS ERIC, who will introduce the ENVI Hub next, the European Environmental Research Infrastructure Cluster's effort to create a single fair entry point to essential climate variables across 27 research infrastructures. He will also highlight the ENVI Hub's integration pathways with the GEO Knowledge Hub. This will be followed by a talk from Alba, who's going to present the Geospatial In Situ Requirements tool. So GREX is a structured way for users to tell GEO what they actually need, where the gaps are, how precisely they need to be filled, and what is blocking access today. Then the third speaker will be Francesca Piatto from the European Association of Remote Sensing Companies. Francesca will present Enforce, a Horizon Europe project that harnesses citizen science and innovative technology to bridge the gap between locally collected environmental data and the standards required by public authorities for compliance monitoring and enforcement. Then the fourth speaker is Eleni Athanasopoulos. I hope I haven't butchered your name, of the National Observatory of Athens, and she will be presenting a synthesis of 4 Horizon Europe projects that between them illustrate what innovative non-space observation looks like in practice. The common thread here is a lesson about what it actually takes to keep instruments running autonomously in harsh places on budgets and how these deployments are scaled. And to close off the session, we'll hear from Helen Glaves, a co-chair of the in-situ data subgroup. So Helen will take us through the in-situ data strategy and set out the strategy's pillars and the roles the strategy proposes for GEO going forward. So her talk is the one that presents a community-driven framework for the technical work we're discussing today. So in closing, we'll hear about a hub, a requirements database, a compliance framework, a portfolio of field deployments, and a strategy, 5 pieces of information on the same puzzle. So after the talks, we hope to have an interactive Q&A. So please jot your questions down as the speakers take us through their presentations. So Alessandro, over to you to present the ENVI Hub next. Thank you.
Thank you. Do you have the tool for the slides? So, good morning, everybody. I'm Alessandro Turco. I'm very happy and honored to be here in this GEO symposium. And I'm from EPOS ERIC, but today, if I manage to move the slides, sorry. Okay, so today I will wear my Embry hat, and I have to thank the Embry Hub Next project coordinators that trust me to give this presentation to you and to explain what is Embry, what is the Embry Hub, and what is the work in progress for the integration between the Embry Hub and the GEO Knowledge Hub. So this is me. So nothing very interesting for you, apart from a couple of things. First of all, it's just only a couple of years that I'm in this field. Previously, I worked in a private company, a software company. So be patient with me. And the counterpart of this is that maybe I can have some fresh ideas or point of view on the topic, and I don't know if this will be a silly idea or not. That's up to you to judge, and please give me your feedback afterwards. So indeed, I'm going to have to present a community, the Embry community, that of course is made by 27 research infrastructure. It includes 4 environmental domains, and it has been funded by several EU projects. You have the list here, and we are already preparing new projects for the cluster. But the truth is, Embry is a community of people, and my idea is that good things happen when good people are working together, and they are working together in a good way. Just a brief thing. I was at EGU a couple of weeks ago in Vienna, and one of the main topics there was data resilience, and I was expecting to hear a lot of technical discussion regarding redundancy of databases, high-speed connection, geopolitical things, but what impressed me in that conference, and this is the main message I want to bring you today, was that at the end of the day, the most critical element in all the data resilience problems and solutions that were presented was the human element, so people. And the fact that if a person is missing for whatever reason in a critical position, it's much more difficult to replace this person rather than replacing a database, replacing an observation tool or whatever. And that's the same idea for the Embry community. So there are the research infrastructure, the European projects, but the reality is that there is, and it's growing, a very active and collaborative group of people that will continue working on 4 environmental domain to bring together data, services, and anything that can be used by scientists in this field. So the Embry Hub Next is the current project, is a project that has a very specific objective. So to renew and offer a single entry point, a unified access to environmental data, thanks to interoperability framework with a strong focus on essential climate variables, because of course nobody can do everything, so we decided to focus on the most important element that has been recognized worldwide, so the essential variables. And we are doing this in the open and fair way, like it's I would say mandatory for advancing science, with the most recent technology. So the cloud-based nature of the portal is paramount in this. So The Embry Hub next project hasn't finished yet. It will finish next January or February. But the Embry Hub is already in production. So you can either go to this website or scan the QR code and you will be there. And you will find let's call them macro services that you see in this slide. So a catalog of services, a catalog of data, a catalog of training, a knowledge base that works together with the AI environmental expert, and the programmatic access to the Embry Hub services. Let's dive a little bit in this. So I think that I do not have to explain to you the essential variables. I think that everybody knows them better than me. Anyway, they are defined at global level. Some of them are simple variables, so directly linked to observational measurement. Some others are more complex and they require different variables to be put together. This is to explain the complexity, and our answer to this complexity was to enforce the use of standards and to homogenize and harmonize the languages spoken by the different elements. So for dataset and services, we use the EPOS DCAT EP profile. For ACV metadata harmonization, we work with iAdopt and the NERC vocabulary server. And since I have a very short time, let's go to a very quick workflow within the hub. So the user may start with the knowledge base. The slide is empty by purpose because I want you really to test the hub. So go there and try the knowledge base. In the knowledge base, you have a search engine which will provide you a lot of resources. Is somehow to some extent similar to the GEO Knowledge Hub with the structure, just to explain to you how it works. And on top of this, we built an environmental expert that is a dedicated AI-assisted chatbot. So it's not ChatGPT, it's a model trained exactly with the elements we have in the knowledge base. So it's very specialized on the topic. We have the catalog of services that is built upon the EPOS open source platform, where you can visualize, you can look for data sets and visualize them in the map just to advance your knowledge and to have a first preview on the data. And then we have the analytical framework that is a Python library that wraps the catalog of services and returns values and any other help functions into a Python environment to analyze the data in a single way. Now, this is what is the Embry Hub. Now the Embry Hub is moving forward. Let me do my institutional part of the job. So I want to highlight once more the fact that the catalog of services is built upon the EPOS open source platform. And this is important because it's open source and it can be used either in also in other contexts. So if you want a map-based interface to show your data, you can go to the web page of the EPOS open source platform and plug in your services and your data. This is included in the Embry Hub, and the Embry Hub now is moving towards a EOSC node. It has been enrolled for the second wave of EOSC nodes, and we are working, and that's why I'm here, together with the GEO Knowledge Hub to exchange data and services. We foreseen 4 pathways. We have a prototype for 2, and we are working on the remaining 2. So this is the first one. So from the Embry Hub, from the catalog of services to the GEO Knowledge Hub. So thanks to the harmonization work we have done in the catalog of services, together with the Python library, and thanks to the work of the GEO colleagues, it was possible, and I think, relatively easy, you can comment on this later, to retrieve the services in the catalog of services within the GEO Knowledge Hub. I suppose this is a staging environment, not the production one, but still this proves that the linkage is possible. Vice versa, from the Embry Hub point of view, we managed to harvest and to index the content of the GEO Knowledge Hub inside the environmental expert that now is able to answer specific questions regarding the GEO Knowledge Hub packages with hopefully the right answers. It's up to you to try, and if you find any errors, please report them to me. The other two pathways, to conclude, are from the GEO Knowledge Hub to the catalog of services. So some packages in the GEO Knowledge Hub has a data set within them, or they include services to access the data. And we would like to have a metadata mapping between the GEO Knowledge Hub and the Embry catalog of services, so that we will be able to list also those services if the governance and all the back-end requirements are fulfilled. But we still we want to start from the technical assessment of this. And the last one is to have the vice versa indexing. So from the Embry Hub knowledge base to the GEO Knowledge Hub, so to have more content available also in this platform. That's it. I hope the time is good. So thank you, everybody, and thanks again for the invite.
Thank you so much for that, Alessandro. And just a note, if you have any questions, please note them down. We'll take them at the end. But thank you for that presentation, and it highlights how you're enriching the GEO Knowledge Hub with content. So next we'll hear from Alba, who's going to present GREX. So this is the way you can tell the GEO community on what in situ data you need. So Alba, whenever you're ready, over to you.
Thank you. Thanks a lot for the introduction. Hello, everyone. Okay, I will try to, So I'm going to present, as mentioned, the GREX, the way you can tell us what in situ data you need. So, this is an agenda. I am going to, present the tool in a nutshell, and then the progress that we have done and the different pathways and examples that we can show. And then all in all, input for the GEO in-situ data strategy implementation, and also the progress on the integration of GREX in the GEO infrastructure. So for the people in the room that doesn't know GREX, GREX is the Geospatial in-situ requirements. Is an open database tool, standard methodology for capturing user-driven needs and requirements for in-situ data, especially within the GEO context. And among the objectives, GREX allows to identify technical barriers to data access and use, reveal gaps in spatial temporal coverages, and then with the information gathered, we are able to make recommendations for in-situ data improvements. We turn the focus to the data users' demands, as has been mentioned in the plenary before. And all in all, also to inform observing networks and data providers, and to support the implementation of this GEO in-situ data strategy. In summary, the GREX data template. So what a user GEO activity participant needs to do when going to the database. So first is asked, why do you need in-situ data? Because in-situ data is needed for many other things beyond calibrate and validate remote sensing data. No? So the user starts thinking on which is the need, and then is able to provide the characteristics of this data that is required, no? In terms of area, the essential variables, and many other aspects of geographic information that all of you know, but these details are very important to us to then work upon them. And for now, the database has more than 100 requirements and more than 20 geoactivities represented, and we are doing this work since 2023, so yeah, almost 3 years ago. And the process, how to contribute. If some of you want to contribute in GREX, and you have not been already contacted by me. So you know that we offer our availability to conduct these guided telcos where we provide support to the users to document all these requirements. That is not straightforward, but it's not so easy as one can think. And of course, we can then discuss via email and so on. We have resources in our, for instance, new website, and where there is the open requirements database and the submission module when you on your own you can report these requirements. And if you want to know more, there is a poster outside and you can come and talk more. Okay, I don't know the time if it's good, but now I am going to explain that in the left side of the slide, we can show the process that we have been doing, collecting all these in situ data requirements. Then in the right side of the slide, we have the different pathways, the different approaches that we can do, we can act upon on this information. If there is a new sensor or perhaps a provider that the user already didn't know, or barriers or gaps identified. So let's see some examples on how these pathways, how we are working on this from the requirements hosted in the GREX database. This is a first example, use case. So GEO Human Planet requires data on construction materials of buildings for disasters risks assessments in human settlements. And so they have explained it to us that they require this kind of specificities about these construction materials of buildings and all that characteristics are there. Then, sorry, because I don't see very well the slide, but I will try. So, and then we have worked on this information. We have researched it. So we have found that cadastres, official censuses, and household surveys are the main sources of this information. So public data. Then nighttime light products that have been mentioned before in the plenary as well are very used for mapping human settlements, but not so useful in this case. And then urban plans, we also realized that urban plans, the BIM, the building information modeling information that is generated during the construction of a buildings or a neighborhood or so on, and that it is not well preserved. So we have been able to extract some recommendations from this. And so for the Commission or whoever needs to give funding, promote projects that harmonize BIM and GIS to better preserve the geospatial data about the built environment, and also improve this coordination with cadastres and municipalities. This big issue. And so this is one of the examples. I am going to explain another one. We have here the case for the geoland degradation neutrality. One user on behalf of this activity has explained it to us that that has requirement on flux towers measurements. Because for monitoring the SDG land productivity indicator, so has provided to us some characteristic on the data that the user asked, in this case for the net primary production and gross primary production variables extraction. So which is the current data landscape sources and limitations? So we see that there is a lack of coordination, even if these measurements are more or less well coordinated, but FluxNet, but however, more coordination is needed. And perhaps this data is available, but is not in perfect state as we can imagine. Currently, it's nice to point that there is the Mona Lisa European funded project that currently precisely is looking at to discover if there are enough towers, we need more, they are well distributed, so these kind of things. So our recommendations is, in this case, we were able to make a kind of calculation not on the data that the money resources that are needed not to harmonize, to create an harmonized product of flux measurement, and you can see here the results. As I think that the time is not 2 minutes. I will skip this other example, but we have more, and we will put these examples on the website. So if you are interested, please. But here at the end, these 5 squares is because we, with G-REX, as we are extracting information for the GEO, we think that these can be inputs for the implementation of the GEO In-situ data strategy. And so the first already have been explained that, but here is to highlight different topics, different kind of things and issues that came up. For example, the third case about the maining activities, the involvement of citizen science and universities in areas in the world that are perhaps, that is difficult to access to this data also from remote sensing, because the satellite cannot see, because the canopies, because the clouds, because there are activities that move very fast. And then in this green one, sorry, I will finish right now, but this green one, from the GeoBond, so this importance of the ecosystems and the biodiversity monitoring, we have been aware about this new ODOK center, and of course the integration of not only the EMBRIS, but the other research infrastructures is also a thing to take into account. And finally, also a case where a new sensor, low-cost sensors could fill some of the gaps that, in this case, on the solar irradiation domain still exists. And so the pathways here more or less demonstrated, so that sensors, if there is a sensor that can fill some gap, yes, and then the others, some barriers identified, some gap, and then of course the providers for this matchmaking, as most of the users we work with, and they are experts from long years, so we are not still approaching this pathway so far. And finally, the G-REX, we know that has been started to be integrated in the new GEO infrastructure. Thanks a lot, because we were very happy to see these tests, and we are looking forward to see more and continue working in this, because we have more years funding to work in G-REX. So so we will continue here. Thank you.
Thank you so much, Alba, for that. Your work really is helping us understand the needs of users and how to address them. So next, we'll hear from Francesca Piatto from the European Association of Remote Sensing Companies, and she's going to present Earth Intelligence for Environmental Compliance, so integration of Earth observation and citizen science through Enforce. Francesca, over to you.
Thank you very much. Can you hear me well? Yes. Thank you so much. So my name is Francesca Piatto from the European Association of Remote Sensing Companies. And today I'm going to talk about Earth observations and citizen science through the Enforce project, and how this project supports Earth intelligence for environmental compliance. That's great. So a quick word about our associations. We are a membership association in Brussels, not for profit. We represent the Earth observation downstream private sector. Across Europe, we currently have more than 130 EO companies actives and registered in 25 countries. And we represent this sector across the full value chain, from data acquisitions to the final service. So I'm very happy today Indeed, to speak about Enforce, which is an Horizon project which really wants to close the gaps between citizen science and environmental compliance monitoring, as it is a very big topic right now on how to transform a large amount of environmental observations data into trusted evidence that can support regulatory actions. Citizens collect data and observations into many through many in many ways, from community monitoring, mobile apps, sensors, documentations, and so on. But it is still very difficult for authorities to really make use of this data, right? And to integrate, especially them, into authoritative workflow. The challenge is not about having more data, but rather how to make this data more robust, traceable, interoperable, and legally usable. I will really focus on legally usable because this is also the main point of the environmental compliance in this project. So the response from this project is really make sure to integrate citizen science data, Earth observations, and AI analysis, building different methodologies and tools to really make sure that we can increment the quality and usability of citizen-generated data for environmental monitoring, compliance, and enforcement. This is done through different case studies across Europe, across different environmental contexts and challenges. So from water, waste dumping, biodiversity, water quality, forest management, urban pollution, and all of these case studies has the same objective. So really understanding how citizen data and Earth observations can support environmental compliance. And this is where the framework and the concept actually of the data readiness level appears in this project. I had the opportunity already in February during the sessions of ODOK to already start presenting also through our main partner this legal framework, which is now ongoing. And this is a framework that was developed already in the past for information technology, really to assess the health and the usability of information systems, and then has been, let's say, adopted and extended by Enforce, really to assess citizen-generated data and EO data together in terms especially of what we call fitness for purpose for regulatory use. Because in terms of, for us, it's very fundamental because the required level of data maturity really depends entirely on the usability of this, of how this data will be used. So this framework really is central because it provides a structured way to assess how environmental observations evolve from collected citizen-generated data into valuable environmental data that can be useful, especially at legal level. Here we can see on the top bottom the different scale of data readiness level, which is divided into different phases from sparse and validated citizen data to the final one, which is applicability, where the data is actually usable for judicial use. And this data readiness level scale also works with integrated criteria that you can see here, because as much as we want to use the data, if the data is has a very low, let's say, data readiness level, cannot then be used for specific requirements. A specific case study that I want to use this is really to show how the data readiness level then can support, for example, frameworks directive, in this specific context, the Water Framework Directive in the Devon region in the UK. Here is where it's very important, the data readiness level, especially the final step, the data readiness level 8, because this is really where Earth observation comes in, and is essential used for independent, continuous, and spatially consistent evidence that can validate what the citizen can actually see on the ground. And this connection is really what we see in this case study, because about its agriculture and water quality management in this region. Under the Water Framework Directive, member states are really compelled to maintain a very a good ecological status of the riverbeds, but it's not really easy in concrete terms, in the sense that usually agriculture and sewage pressure really tackle these river systems, and also the regulatory monitoring is not that easy to do due to scarce, costly, and sometimes frequently in situ sampling. So there is really a gap in the monitoring gap between what the actual framework directive wants the member states to reply on and what the actual realistic measurements we can get on the ground. So within this case study, for example, these connections between citizen science, Earth observations, and an AI to monitor and to run the, let's say, patterns, for example, of erosions or pollutions, really, let's say, bring all of this together, and especially supporting this, let's say, data readiness level from less validated to a more applicable environmental reports that people can also, or citizens can use at legal level. Yes. In order to conclude as well, we see how we can operationalize the data readiness level framework through the final Plaza toolkit. This is still under development. And it's really a way where we can bring together all the different typology of data and services. Here in this plaza, we can really see where how typology of personas can really access it and use it and make sure that they can report, for example, environmental crimes that they feature, for example, that they see in their own countries. And they can log in by identifying themselves as citizens, as policies, as analysts, as regulators. And from this, by injecting all the different informations and data, they can actually prepare a report. And this report will really be developed and attached with the data readiness level, which we will show the readiness as well of this report and how it can be shown at different stages, from court hearings or to different into different setting. So for us, this is really important. It's still under development, so we're still running some tests. But we really think that for the moment it can really provide a legal way to really make a concrete assessment of this data. And to conclude, what I wanted to say is that I had the opportunity already in February also with Ellen and the team to showcase Enforce as a project where really the citizen science in situ and Earth observation and typology of data can really support as well the future GEO in-situ data strategy, but also in conversation as well with our project consortium, also understanding how the Enforce project can actually also benefit from this GeoWork program and the GeoKnowledge Hub, for example, in terms both of discoverability, different capacity building supports, of course, disseminations. But then I'm very happy to see as well also through the different presentations as well of how, for example, GREX could support or repos in this sense. So I think that I will also be very happy after these presentations to go more into details of this. So thank you very much.
Thank you so much, Francesca, for highlighting that citizen science element. It's often underappreciated. So now we'll hear from Eleni Athanasopoulou from the National Observatory of Athens, presenting innovative non-space Earth observations to resilient decisions around climate hazards and waterland services.
Thank you. So I am Eleni Athanasopoulou. Hello to all. I am a research scientist at the National Observatory of Athens. But here I am first because I participate in a European project, Sirocco, and one of my tasks there is to make the liaison between GEO and activities and the project. But then I am also here as an ambassador, let's say, to transfer the cooperative experience to the broad community here, strengthening the in-situ component of Europe and beyond, because as you can see there, contributors to this presentation are four projects that are relevant with each other. I will explain more later. And I also want to thank the representatives, Zhen Zhu, Rolf Ruffenacht, Nick van der Giesen, and Chrysoula Papathanasiou from all projects and institutes that have provided material for this presentation. So if you remember, in 2019, in the ministerial summit, with respect to observations, it was highlighted that there are both spatial and temporal gaps with respect to environmental information, which was also mentioned and recorded, let's say, in the Canberra Ministerial Declaration. These gaps and this request was addressed by the European Commission that were interested to fund projects that are relevant to new technologies from non-space, so ground-based, and that wanted to explore the climate change impacts. Several projects won these funds, and their commonalities, let's say, are cost-effective. I will mention now some keywords that are relevant to all 4 projects: cost-effectiveness, sensors, poorly observed or harsh or remote environments, operationalization, and climate change adaptation and mitigation. Coordinated by Sirocco, we created a cluster of these projects that it is named DL cluster. And what we want to achieve by clustering is to foster collaboration among all scientists and projects, to share our knowledge from working and implementing in the cases, and of course to amplify impact with respect to climate change, which is a global issue, and joining forces is always beneficial. Okay. So, a few words about its project. UAWOS is a project named after Unmanned Airborne Water Observing System, and they have developed a drone-based water observation system that provides hydrometric information over rivers. Then EULIA project, the acronym stands for European LiDAR Array for Atmospheric Climate Monitoring. And again, they have developed a low-cost ground-based LiDAR that it is also easily transportable and measures atmospheric information in the upper atmosphere up to stratosphere. Then it is Tempo Africa, transformative environmental monitoring to boost observations in Africa. Again, cost-effective sensor networks and support flood early warning systems, so they support services with respect to floods, reservoir management, and crop germification insurance services in sub-Saharan Africa. And then it is Sirocco, that enhances the in-situ environmental observations across undersampled deserts over Europe and Africa. This year's theme of our convention here is investing in Earth intelligence for a resilient future. So I tried here to highlight the components of the scope of this meeting that we are doing here in Geneva. I have selected some highlights here from each project. This does not mean, of course, that, for example, Sirocco or Tempo Africa does not produce open data sets, but as I said, I have highlighted some contributions. So indeed, UAWOS provides open data sets with respect, as I said before, to river observations. Then, with respect to interesting user stories, of course, all projects provide, but EULIA could provide some from Norway and France with respect to the field deployment of their LiDAR. As I said before, Tempo Africa focuses on CO2 benefit solutions because they are focusing on 3 solutions. And then with respect to Sirocco, I need to highlight the collaboration between the research and the private sector. So in the consortium, private sector is present, and they are manufacturing the atmospheric measurement system for the desert areas. Now, I have interviewed these people representing the projects, and I have asked them 3 questions. The first one was which types of instrumentation you are developing, and which data products or tools you provide that that can support broader in situ initiatives. As you can see here, answers are relevant to the drone-based hydrometry, to networks of autonomous, as we said, LIDAR measurements of the upper atmosphere. Then we have local sensing nodes, actually 6 or 7 different sensors that monitor flood information, flood relevant information. And with respect to Sirocco, several environmental parameters, either meteorological or air pollution. And all these data are open and available. You can see with the yellow colors where this data come from, and of course these are valuable for the broader community. The next question was relevant on if we do public sector partnerships, and with respect to answers, as you can see, with respect to rivers, the hydrometeorological survey departments and water resources authorities were collaborating and actually responsible for the demonstration cases in the 6 rivers of Europe. In the case of Norway, Germany, and France, and the LiDARs to measure upper atmosphere, there was it was not in the partnership of the project, but there was a dialogue and coordination with the local authorities to install and operate the instrumentation. With respect to the flood early warning systems, there was a collaboration with the Kenyan Meteorological Department for these 2 counties that the system is already working. And in the case of Sirocco, not only in Cyprus, but also in Serbia, we have in our partnership local authorities, so that the network of sensors is installed and then operated and maintained. Third question had to do with challenges, which I think it is a lot important with respect to environmental monitoring with low-cost in-situ sensors. They have reported the challenges, but I mean, I have separated them by project, although I think that most of them are common. For example, you see extreme weather conditions, either it refers to the upper atmosphere, or it refers to the riverside, or they refer to the desert areas. There are operational challenges, not only construction, I mean, challenges. In case of Africa, where the resources, either by humans or by funds, are limited, this was indeed a challenge on its own. And with respect to Sirocco, we found a lot of communication challenges between the sensors and the transmission system. And because the areas are remote and you need to have a multi-connectivity system in the infrastructure, so that this can support the transmission of data. And also it was a challenge to see what are the trade-offs between cost and accuracy, or between running the sensor continuously versus autonomy of the system. And how to have a long-term reliability with respect to quality assurance and quality control of not only of the data, also of the sensor. Last question had to do with replication and scalability. And indeed, all projects have produced systems that can be replicated in similar areas. You see, for example, that in any ungodged regions, the system of UAGOS project can be introduced and implemented. I have to run, I think, so I will not read and explain everything. As you can see in the case of Sirocco, the system is modular and expandable, so that more sensors or more, or more atmospheric parameters can be measured. Here, what I wanted to do with the outputs from those interviews is to explore the GEO In-situ strategy in conjunction with the outcomes of this cluster. So you can see that indeed there are common design requirements, there are open and new and open data sets. All projects have shared knowledge with area managers, local decision makers, or customers in the case of Africa. A lot of common operational challenges with respect, for example, to extreme weather, or with respect that all challenges are relevant to the regions that are all remote, and of course human factors. I asked them also to share a word from their experience up to now. And here you can see that Chrysula, for example, from the Sirocco, mentions indeed these common challenges that scientists face from the alpine areas to the desert areas. How important is to have electronic sensing in areas like sub-Saharan Africa. Then how important is to design autonomy in the first place and not add it, leave it as an added on later. And then last from Zen, the integration between EO and in-situ data. That was all by my side. As I said, I am here as an ambassador of this knowledge. So you can find here the contact information of all people that have provided this valuable material. They were also convening together the previous weeks in the EGU, and we plan to convene again together virtually through a webinar, so that they can respond to questions with respect to in-situ monitor, not in-situ, ground-based monitoring. That was all by my side. Thank you.
Thank you so much, Eleni, and thank you for sharing thoughts on alignment with the GEO In-situ data strategy, which brings us to the final talk by Helen, who's the co-chair of the In-situ data subgroup. So Helen will present the In-situ data strategy.
Thank you very much, Leo, and thank you to all of the previous speakers who I think have set the foundation for what I'm about to say about the activities of the in-situ data subgroup and the work that we've done to develop an in-situ data strategy. I have to say that this work has been very much a bottom-up activity. that has been supported by the whole community. So this has not been a small group of people in GEO. This has been a truly community consultative activity. And we have confidence that the strategy that we have arrived at has very much been a reflection of the input that we've got from a whole range of different people, including a number of the people who sit around me today. So I'm going to say a little bit about the in-situ data strategy. I would urge you to read the document because I very much am going to give you an overview of what are the most important points in the document. So just to lay the context of why have we developed this strategy and what was the mandate that was handed to actually the Data and Knowledge Working Group and the in-situ subgroup. In-situ data has become a priority for GEO over a number of years. And in fact, as already mentioned, the Canberra Declaration specifically identified the need for GEO to have a strategy that related to in-situ data. So in fact, indeed, in the ministerial statement from the summit in Canberra in 2019, it specifically calls on the GEO community to develop this strategy that addresses challenges in the area and also demonstrate progress in implementation. I think what we've already heard here this morning demonstrates the fact that the in-situ landscape is in fact very diverse and very complicated. There are a range of different disciplines with different data acquisition activities, and this is actually creating a very heterogeneous landscape that we need to think about how do we integrate all these diverse activities for the benefit of the whole community, but also to serve the GEO priorities, particularly those set out in the post-2025 strategy. At the moment, the efforts to create and adopt standards are actually limited, and there are actually a number of significant gaps in the areas. So this morning we've heard about GREX, where we've been thinking about what are the requirements and also the gaps look like. We've heard about efforts such as the ENVRI Hub, which is trying to bring together this landscape and to actually integrate a number of the different data acquisition activities. But the first question that we've had to address is, what is the actual value of in-situ data? So why do we care? I don't think anybody in the room would be surprised to learn that actually in-situ data has a raft of inherent values that range from calibration and validation of remote sensing products and Earth system models. We're also thinking about measurements of locations that are actually inaccessible to space-based observing systems. So, for example, within the global oceans, but also areas that are constantly affected by clouds, smoke, or aerosols. The other added value from in-situ data is actually the temporal and spatial distribution and resolution, because together with Earth's observation data, this allows an accurate and more frequent measurement of the Earth system. But also in-situ data, by its very nature, provides a longer time series. And it's also worth noting that in fact, in-situ or ground-based observations are actually the only legally admissible form of Earth observation data in certain scenarios. And I also mentioned that actually in-situ is now part of realizing GEO's mission and the global priorities that are defined in the GEO post-2025 strategy. I mentioned that the current landscape is actually quite diverse in terms of the data and the different assets that are available. And this is actually necessitating significant investment of resources into curation and archiving. And again, we've heard about a number of projects here this morning. This is just a snapshot of the huge number of activities that are currently underway to actually foster curation and archiving of in-situ data to ensure its long-term availability for reuse. There's a huge amount of data management efforts around standardization, harmonization, and interoperability of in-situ data. Alessandro this morning talked about just one example of those in the context of the ENVRI Hub. but we also need to maximize integration and reuse of in situ data. And this requires new and existing and new observing networks to implement these common data frameworks. But we also need to look for wider implementation of common data management practices, such as adoption of the GEO's data sharing and data management principles, but also the widely accepted fair care, trust principles. So what are our key motivators for the in-situ data strategy? I already mentioned that we're thinking about increased coordination of in-situ data providers, but we also need to mobilize GEO members and participating organizations, engage with in-situ data users, and advocate for in-situ open data and knowledge. To achieve this, we actually need to foster a change in the mindset of the global GEO community to ensure in-situ data management and data sharing is an integral part of all relevant activities. And we need to support this approach by delivering the tools, policies, and practices that are needed to maximize in-situ data sharing and integration. And perfect examples of these are the GEO Knowledge Hub, GREX, and a number of other activities that are underway. So what are the strategic objectives of the in-situ data strategy? So we need to think about identifying and monitoring requirements, again, referenced by Alba. But we also need to understand what are the requirements in terms of actually accessing and reusing in-situ data. And we also need to understand what are the barriers to making in-situ data open and available for reuse. Oh, that's going to jump forward now. We also need to think about coordination at different levels. So again, we're focusing on national and regional in-situ data networks across different geographical areas and by domains. And our intention is to try and define and understand this complex landscape, promote sustainability and improvements to observing networks. We need to identify gaps, but we also need to support implementation of the GEO infrastructure that will actively serve as a gateway for in-situ data and stimulate adoption of appropriate tools for data management and integration of new data sources. GEO needs to act as an advocate that needs to ensure that it takes a leading role in promoting good data stewardship, encourages the use of flexible and common data licenses, but also illustrates the use of in-situ data for increasing environmental knowledge and minimizing and avoiding the loss of in-situ data. So I'm going to skip over this slide in the interest of time, but I just want to highlight the fact that in the context of the in-situ data landscape, the in-situ data strategy identifies 7 key roles for GEO across a number of different activities, which range from advocate through to coordination, but also we need to think about GEO as a facilitator, a custodian, and a redistributor of in-situ data. But we also need to recognize the role of GEO in terms of upskilling and capacity building to enhance exploitation of in-situ data, and in particular for the next generation of researchers. So we are thinking now more about how do we implement the in-situ data strategy. And successful implementation of the GEO in-situ data strategy requires a comprehensive and coherent set of actions that need to be undertaken by the GEO community. We need to think about awareness raising, supporting an adoption and implementation of relevant best practices, and ensuring we do provide the tools and the infrastructure necessary to ensure availability and reuse of in-situ data. But fundamentally, we need a strong commitment of national and regional and global level initiative to ensure the availability of the resources necessary to support in-situ data systems and the associated stewardship of the data and knowledge. So in summary, I think I just wanted to convey 3 key messages about the role of GEO in this context. The in-situ data strategy provides a framework for the open sharing of ground-based observation of our Earth system And we received a mandate for this at the ministerial summit level in 2019. And we are now delivering on this mandate. And the in-situ data strategy will be presented for approval at the GEO plenary on Thursday. And I see this as a huge achievement for everybody who's been involved with this process, both current and past. The other thing I want to say is that I think the in-situ data strategy provides an approach that is aimed at overcoming specific challenges that have been associated with the acquisition, reuse, and long-term availability of in-situ data, but also supporting the sustainability of associated observing networks. And this includes also identification of critical gaps that will need to be filled for the future. But GEO also has a unique position in terms of its convening power to coordinate the community at the highest level and foster the adoption of the approaches and practices necessary to maximize the access and reuse of in-situ data. And we should capitalize on these opportunities that we have as a GEO community to support the availability and reuse of in-situ data, but also the associated observing networks. Thank you.
Thank you so much, Helen. I don't know how much time we have left for questions. 20 minutes? All right. So I think we can open it up for engagement. All right, I'll start with Bente.
Thank you very much, Bente Liljaby, BLB, and member of the Data and Knowledge Working Group. So thank you to all the speakers for excellent presentations, very inspiring for us working in this committee. I have a question for you, Eleni, concerning the willingness to share the sensor data. You said that you had the authorities with you in some of the examples that were responsible for these networks of sensor data. We know that some of these data are also regarded as very sensitive, and there is some frictions and some reluctance on sharing this data. Can you share some experience on that topic?
Actually, I understand what you say in principle, and I have seen this happening. But with respect to the openness of data in the frame of these projects, and this is something that I forgot to mention earlier, Sirocco plans to put in the GEO Knowledge Hub all data and information. Actually, we have requested access so that we had to develop a strategy on how to upload, but now I think it is the time. We have already collaborated with Alba, and Sirocco is already in GREX. As they have said from Tempo Africa, they plan to upload in the GEO Knowledge Hub, and they plan to submit to become an activity after the completion of the project. EULIA, as I found out, is already at the GEO Knowledge Hub, I mean the data sets. I have explored the projects, and they share a platform, and they share the data sets from these harsh environments. So to tell you the truth, I haven't heard of any difficulty in sharing data in the frame of these projects.
Okay. I think the second hand I noticed before was from.
Yes, thank you again to all the speakers for the very inspiring messages. So I have a comment for Alba, and so for context, this is regarding the eddy covariance measurements that you had mentioned, and I am from ICOS, the Integrated Carbon Observation System. We are an environmental RI, and we have 106 stations measuring exactly eddy covariance measurements, high precision, standardized long-term measurement. So, and we have also been coordinating with regional ecovirence networks to create the FluxNet measurements, which you mentioned. So I think, granted that the biggest FluxNet release was in 2015, but now I think you'll be happy to know that ICOS, together with the other regional networks, have come up with the FluxNet Shuttle, which is a new tool which will have more continuous release of the flux eddy covariance data sets. And I think it also calls for closer cooperation with GREX and ICOS and also with the rest of the FluxNet community. I think the time is quite ripe. And at ICOS itself, we are heavily involved in a project called Nubicos, where we are actually working together with the satellite community to define protocols for variables like leaf area index and land surface temperature, and also photosynthetically available radiation, FAPAR. So we are very excited and we look forward to more discussions with you and the rest of the GEO community.
Thanks a lot for your comments, for your interest. Of course, I am not an expert of flux measurement, so most probably, so you know more. Thanks a lot, and of course, I will come to you later, and and we can exchange.
We should talk.
Yes, thanks a lot.
Thank you. I'll take a hint from you, sir.
Yes, thank you. Mark Denman with the World Resources Institute, based here in Geneva, but fascinating conversations. 2 quick questions, and also congratulations for setting the strategy. I know strategy process is really challenging to do all that. I'm new and learning more about the GEO world and in-situ world, but I would love to hear your thoughts on how you're linking and thinking about the strategy to unlocking finance to support this. I know I'm coming from more the water sector, and there's a lot of interest from MDBs and the investors in the finance sector on outcome-based financing. But of course, getting on the ground measurements that could then move from kind of modeling outcomes to the impacts actually having to, in this case, specific watersheds. And I was really excited to see where the strategy is going and merging satellite with in situ. But then thinking of, are you hearing there's an appetite for these funders to also fund the data infrastructure behind all that and to take it to the next level? So one is linking in that to financing. And then the second quick question is related to more to enforce, to Francesca. Love to see the case studies. And I was just curious on how maybe deep into the supply chain or the value chain that your work goes. And we can, I can talk more about the work we're doing, kind of seeing on the ground and the different gaps, but with seeing of, using the enforcement are you going to the tech companies where a lot of either, in this case, maybe critical minerals is in there, they want to have their battery passports, etc. But was curious on where you're drawing the line in terms of engagements in the supply chain of companies trying to report for EUDR or whatever it might be. So thank you.
So maybe I'll reply to your question about, the plan for implementation and how we, aim to secure resources for that. I think the first thing I would say is that we are very much in the initial stages of thinking about what implementation looks like. And part of that implementation plan needs to be developing those partnerships that actually can draw in resources. And that will inevitably mean that we need to identify partnerships, including potentially with the private sector. But also there are a range of organizations and activities, funded activities, that we would hope to leverage in order to actually move forward with the implementation. But again, we still need to do quite a lot of thinking around what that looks like in terms of developing that implementation plan. So I think, in short, that's kind of where we are at the moment. I hope that answers your question. Paola's going to add to that, no doubt.
Thank you very much. Thank you, Ellen, for yes, providing the answer. There is, I think, another part of the answer that is important to mention here is that the in-situ data strategy implementation will be joining the implementation plan of the GEO infrastructure. And there are very important aspects to be mentioned here. First of all, GEO, we believe, we advocate open data whenever possible, whenever this is the case, whenever it doesn't conflict with other elements such as privacy or targeting wrong information and so forth. So open data is very, very important, and data sovereignty is very, very important. We are a community, as Alessandra was saying. The power of GEO is a community. It's a community of people who work together in trust to advance the data sharing, the management, and the preservation of data for our planet. So we're very interested to learn and to collaborate with potential funders, absolutely, within the GEO infrastructure, by making sure that we protect certain ethical principles that is core for our community. Thank you.
Thank you. Francesca, do you want to answer the second part?
Yes, I can comment very quickly. So I think your question was indeed the most how we're going to enhance as well the data readiness level and how also the different users can use this, right? So for the moment, we are really at the beginning of this framework. To be completely honest, we had some short back on this due to some problems at consortium level, just health-wise. So we have a little bit of delay on this. But the way we started, it was really a survey at community level, really to understand how they see themselves in terms of using data readiness level, what is the approach, if familiar or not. And then the next steps will be really understanding how, for each of the case studies as well, they can connect with this data readiness level framework, because each case study has a different data readiness level due to the different as well environmental context. So maybe some case study would require very high data readiness level to be admissible, for example, to hearing courts and such, and maybe other ones way much shorter. And this, of course, will also be impacting also the uptake as well of this framework as well for other typology of users, notably companies. You definitely mentioned mining. So also this will be, if there will be any kind of reporting based on misconducts or environmental infringements, for example, the data readiness level will be then sort of connected to that type of report. So it's very feasible, the thing, but we're happy to share more when we will advance, of course. Thanks.
Thank you. I'll take your question.
My name is Josh Lyons. I have two questions. First for Francesca, and the second is for all of the panelists. First question, the DRL levels, it sounds fantastic. My question in practice is, who actually is responsible for assigning said levels? This seems like, given the complexity of the data and those levels, it seems like it could be a full-time job, and I'm curious exactly how those levels are assigned. Second question, a little bit more serious. I wanted to specifically ask the panelists if there had been much discussion or ongoing standards being considered for the protection of the scientists, the citizen scientists, the community activists who are actually going to be and continue to be involved in the collection of all of this wonderful in-situ data. Because in most countries, people face threats of violence in the act of collecting this data. Thousands of people have been killed in the process of collecting in-situ data. It is inherently a political issue, an issue of power and authority and control, unfortunately, in many countries. And increasingly now, I've many humanitarian colleagues who are involved in the use of new technologies in humanitarian contexts, the technology is rapidly weaponized against them through misinformation and disinformation. And my fear is that a lot of EU funding in particular is now going into encouraging very vulnerable people and vulnerable communities to be more involved in data sovereignty and collection. And in particular, it's exposing people to hidden threats of violence and in some cases, wrongful imprisonment, because they have apps and data on their phones that are exposing them to levels of risk that they're not aware of. And I'm afraid that I've seen many EU-funded projects that I find extremely problematic for these reasons, and I'd just like to know if, to what extent is this issue of protection of people part of this discussion. Thank you.
Thank you very much for your question. So I have some notes about the data readiness level that I would like to share indeed, because of course, this framework was, let's say, expanded upon the data readiness level that was already originated from different other disciplines. So then I know that it was started as, originated from information technology to assess health and usability of information systems, then adopted to data science as well. And then Enforce project with our partner has adopted and expanded it towards this different level of data readiness. So I won't go into details. They are divided into 4. So I think indeed from exploration, where data is unverified, to development, where data becomes more structured, to verification. So here is where the data becomes applications ready, and then applications where really the data is fully mature and used to the highest, let's say, levels, and where spatial, temporal, juridical, precision is required. So I know that part of this has been developed directly by our partner, who also already develops the so-called MINCA applications, which is now also recognized under the UN as a citizen science repository that gathers already, I think, more than 5,000 imageries and observations already from citizen science, already validated as well by different amount of experts from research to private. So quick answers, no, I don't know, but this has been, let's say, the path, the journey that brought us to the definition of these 4 specificities. I will be happy eventually to put you in contact as well with our point of contact from this. Thanks.
Sorry, Joan, was your hand raised?
I wanted just a quick reaction because we are kind of colleagues in this particular call, no? I'm in this other project that is sister project that is called More for Nature, also citizen science. I just wanted to say that the European Commission is actually forcing us into strict ethical protocols. The ethics is not only a deliverable that you do because it's paperwork. In the case of citizen science, at least in More for Nature, we take that very seriously. Actually, we have a deforestation case in Cambodia where we had to activate these ethical protocols due to exactly the risks involved. There are maybe more risks when you do activism than when you do monitoring, but even when you do monitoring, there are risks involved, and we already have found the case, and we know how to react because we have those protocols. Thank you.
So I'm just going to quickly augment what Sharon said, because I want to emphasize the ethical axis there, because increasingly, as we are thinking about co-design with the community and co-production, part of that thinking is very much based on what is the ethical framework that we need to put around those activities, because we are aware that in certain circumstances there are potential risks. And I think it's not just in the context of EU projects where there's mandated that we review the ethical aspects, even more broadly. So for example, I actually worked for a geological survey in the UK, And we work in a number of countries around the world where this is an issue, where we are co-designing projects with local communities. And part of that includes a risk assessment, not just for our own staff, but also for those people on the ground who are working with our staff. So I think there is an increasing awareness of the need to have that grounding in ethical practices to ensure that we can continue to make the data available, but also ensure that those who are involved on the local level in the process can be, number one, made aware of the potential risks to them, but number two, in some circumstances, provide protection for those people, whether it's physical protection or just anonymizing the data and the source of that data. So there's a whole scale of activities that can be put in place. I hope that answers your question at some level.
All right.
Right at the back.
Sorry.
Next.
I think we have only less than 2 minutes left, so I'll take that hand and the hand at the back and move to a closing.
Yeah, thanks for all the presentations. I'm Mark Noord of HEP International, participant in the Tembo Africa project. So I wanted to come back to two issues on finance and coverage. Although in Tembo Africa, we propose to do things 10 times cheaper than the conventional method, finance is still a problem. You need simply funding to get in situ data, and we specialize in the hydromet data, and there it's an issue. What we try to do is by the delivery of services that we can, so it's the delivery of services to generate income to make this possible. So that is one thing. And the other, where of course we need the support of GEO, is to talk with the hydromet agencies in the African countries so that they make it publicly available. That is the other. We always will have the constraints. Our best paying clients are hydropower companies, and they really want to have their data confidential, but it facilitates to make other data available. So indeed, it is an issue that needs to be solved, this financial issue, but there are ways that we are trying to do it. And with the coverage, the GREX exercise was very interesting for us, especially because the problems we are facing in Africa is more of not so much of the quality of the data itself, although that in some cases can be improved, but it is a geographical coverage of having more hydromet stations in Africa, because that is where it is totally lacking and falling short at this point. So that is something that also in a GEO context we want to keep promoting. So thank you very much. Yeah.
So my short answer to that would be that we definitely need to have a conversation, because one of the things that we have been seeking to do is to leverage other activities in other communities, because we don't want to keep reinventing the wheel. We want to work together and develop a collaborative community that is not just in one lane, but actually integrates and interacts with other activities. We are all facing reducing resources for many of these activities. And if by combining our resources and focusing on some common challenges, that's definitely got to be a win for everybody. So we should definitely have a conversation.
I think we are out of time. Maybe
There's
like,
one
let's
at the
just
corner.
take
Come on.
that.
Thank you. Just I've been raising my hand since the start. So sorry, I'm just going to bring in a third community to the conversation, and it's the Citizen Science Global Partnership, which is a network that aims to advance citizen science for sustainable development. And we're trying to use citizen science data globally to leverage it for environmental monitoring, but also Earth observations and all the other approaches. And we've been working with the national statistical offices to integrate data from citizen science into official statistics. And we have experience in that process as well. We've been active in the past in GEO, but then the resources issue came about again. And we haven't been so active, but we would love to be part of these conversations again and to work with you all on citizen science and how we could leverage this alongside Earth observations data to address environmental issues. Thank you.
Thank you. And Paula just wants to.
Yes, just before we close, I would like to remind you that the next session will start at 2:00. It's going to be about national geo-knowledge hubs. So a lot of the discussion we are having here somehow strengthen national partnerships and so forth can be brought also to the next session, because we know that by the adoption at the plenary of the in-situ data strategy, members will be owning that strategy and will have to implement them in their countries. And so we follow up the discussion with the national geo-knowledge hubs. Please join us. And back to you. Thank you, Lee.
Thank you. Let's give a round of applause to all the speakers again. I will close off this session and thank you for bearing with us with the time. And if you are attending the plenary on Thursday, please support us for the in-situ strategy. Thank you.